Hello everyone, this is Dr. Lee. So we're going to talk about our next topic for our course, probability and statistic. Right, so today we're going to talk about mainly probability, right? Probability. So we're going to talk about basic terms that they use in probability, like experiment, event, sample, population, and also we're going to talk about a couple of counting rules and some of the basic terms that we are going to use in probability. Right, so let me adjust a little bit so that we can see this. All right, I guess this is good. Okay, so probability is a numerical measure. Numerical measure simply means it's a number, right? Numerical measure simply means it's a number of likelihood that an event will occur. So, something like this. If you flip a coin, what's the probability that you're going to get a head? Well, if you flip a coin, you will have a 50% chance to get a head and 50% chance to get a tail. So, that 50%, that's a probability for an event of getting head when you flip a coin, right? And probability value is always assigned on a scale from 0 to 1, meaning you cannot have negative probability or you cannot have a probability bigger than 1, right? So, you're 100% sure it's good, but if I am 120% sure, I'm 200% sure, technically speaking, that doesn't really make sense. Probability near 0 indicate that it's unlikely event. It'll not likely to happen. And probability near 1 indicating that it's likely to happen, right? Okay. Now, so probability 0, it's unlikely event. Probability exactly half, 0.5, even chance. And probability close to 1 is certain, almost certain likelihood of occurrence. Okay. So, what's statistical experiment? Let's talk about the flipping a coin again. If you flip a coin, the action of flipping a coin is actually a statistical experiment, right? That's discussed in here. The result, whether it's head or tail, is the result of a statistical experiment, right? Statistical experiment determines outcome. So, if you flip a coin, I told you that action of flipping a coin is a statistical experiment, but when you flip a coin, you will have outcome, right? Head or tail. So statistical experiment probability determines outcome. Even though the experiment is repeated in exactly the same way, entirely different outcome may happen. So if you flip a coin, even though you flip a coin exactly same way, you can have tail, or sometimes you have head. So it's all different. So the reason why you have this different outcome is what we call the random experiment. Or statistical experiment sometimes is called random experiment because you have a different random outcome, so to speak. So experiment is any process that generates well-defined outcome, and sample space is set of all outcome of experiment, right? So let's say you flip a coin. The action of flipping a coin experiment, outcome would be all possible case. Sample space would be all possible outcome, so it would be head or tail. Let's say you are rolling a die. You're rolling a die. If you roll a die, you will get anywhere from 1 through 6, right? 1, 2, 3, 4, 5, 6. So action of rolling a die is statistical experiment. The result, the outcome, 1, 2, 3, 4, 5, 6, is sample space, right? All right. So, they have an example. Toss a coin as experiment. Head or tail is outcome. Inspect a part. If when you inspect a part, you have whether you have defective, something's wrong, or non-defective, no error. Not everything's fine. You have two outcomes. If you conduct a sales call, you have two possible outcomes: purchase or no purchase. Roll a die. We talked about this, 1 through 6. Play a football game. You win or lose or tie. Right? You have three different possible outcome. Right? Okay. Now let's talk about this probability in business case. And we're going to talk about this. We're going to use this example over and over again. So it's good idea to take a close look at this this example. So Bradley has invested in two stocks, Markley Oil and Colin Mining. So Bradley has invested in these two different company, I guess, right? So, and Bradley has determined that the possible outcome of these investment in 3 months from now, right? So these are possible forecast. So, and these describe a dollar in thousand. So this would be $10,000. This is $5,000, and this is, I guess, $0, and this is negative $20,000. And this mining would be 8,000, and this is negative 2,000. Okay, so when Bradley invested in these two companies, possibly this can happen, or possibly this can happen. He can make 10,000 on Markley Oil, or Bradley can make 5,000, or break even, make no money, or lose 20,000. That's possible. Or when Bradley invested in this Colin Mining, it can earn 8,000 or lose 2,000, right? Okay, so let's figure out how many possible case for this, losing or gaining money, and we are going to use what's called the tree diagram. Well, once you see the diagram, it's not that difficult to see. So for this investment case, the Markley Oil has N1 means investment case there's a 4 different case. Why is it 4? Well, there's 1, 2, 3, 4 different case for this oil. What about coal in mining? There's a 2 different case. Why N2 equal to? Because there's these 2 cases right there. So in total, how many different combination is possible? There's 4 case for N1 and there's 2 case for N2, the oil and the mining. So altogether, we multiply these two and we have 8 different cases. So we multiply these 2 separate cases to figure out the total possible case. Now let's go to the actual tree diagram, and it looks like this. You can see this tree branch. So this first stage is the oil case. The second case is for the mining case. Remember that the oil case, there's 4 different cases, which was 10,000, 5,000, break even, 0, or lose 20,000, right? So we have 4 different cases for this oil. Well, let's assume that Bradley made 10,000 on oil. Since Bradley also has 2 possible cases for mining, when Bradley made 10,000 here, this branch, Bradley can also have these 2 possible case. 8,000 gain or 2,000 loss. So, if Bradley gains 10,000 here and also gain 10,000, then total gain would be, also gain 8,000 here, would be 18,000, just like that. But if Bradley gain 10,000 here, but lose 2,000 there, well, then gain would be 8,000, like that. So, so the 10,000, 8,000, 10,000, negative 2,000, right? That's these 2 lines. And, all this combination is based on those case. If Bradley lose 20,000, but lose again another 2,000, then 22,000 will be the loss, right? Okay. So this tree diagram explains how many different cases? 8 different cases for this investment options, right? So that's tree diagram. Okay. Now let's talk about the counting rules. Counting rules. Counting. Everybody know how to count. 1, 2, 3, 4, 5. But depends on the question and the situation. Counting can be quite difficult. Imagine that, like, if you have to count every single possible case for organizing, say, flight paths at JFK Airport, right? Some flights coming in, some flights going out, and different time to different destination. Let's say if you have to count all that possible cases, right? Somebody did it, right? There's flight schedule at JFK. Somebody did it. And how do they do it? Well, we're not really going to talk about that type of complicated questions, but we're going to talk about the basic ideas of counting. So this is what we call the combination. N object taken, the uppercase N object taken lowercase n out of time, n at a time, right? So this should be used in a case that, let's say, you have 10 books and you decide to take 4 books when you go to library, right? You have 10 books, this would be that uppercase N, and you're going to take 4 books, which is the lowercase n at a time. Now, if you have 10 different books and you're taking 4 books out of those 10, now how many different possible combination of those 4 books can you take out of 10 books? And how do you calculate that different cases? Well, you use this formula. And that's a notation. See uppercase N here, the lowercase n there, and uppercase N there, look, that's, sometimes you see this notation, sometimes you see this notation, and that's how you do it. This mark, this mark right there is called factorial. So what's n factorial? N factorial explained it here. So you start from n times n minus 1 times n minus 2 times n minus 3 all the way up to 1. And this is another one. Those small n factorial, the same thing. You start from the n, you go down by 1. You keep multiplying. And this factorial right here, that's a special case. 0 factorial is 1. Right? So this is like a special case for this factorial. So think about it. If you have like 10 books, and if you are going to actually take 4 books at a time, how do you do that? How you gonna actually figure out how many different combination? Well, let's see. So according to this, you have 10 books. Take 4 at a time. Okay. So the formula would be C10-4. Well, you can rewrite that as 10-4 like that. I mean, sometimes you even see this 10C4. You will see sometimes this notation. So this or this or this, these are all the same. So according to this formula, right, you can write down that formula, and you can also, I hope you have a printout of this PowerPoint. You can, I uploaded this in our resource, so you should be able to download this PowerPoint. And it looks like this uppercase N, which is 10 factorial over this lowercase 4 factorial, 10 minus 4 factorial. Now, factorial was what? 10 factorial would be what? Start from 10 times 10 minus 1, 9, 10 minus 2, 8, 7, 6, 5, 4, 3, 2, 1. That's 10 factorial right there. What's 4 factorial? 4, 3, 2, 1. That's 4 factorial. And 10 minus 4 factorial would be what? 6, 5, 4, 3, 2, 1. That's it. I mean, calculation seems long. It is. It's not short, but luckily you can see that a lot of things will cancel out. Right? This 6, 5, 4, 3, 2. 6, 5, 4, 3, 2 will cancel out. Right? And let's see. 4 and 2. 4 times 2 is 8, so they'll cancel out with this 8. right? And this 3 will cancel out with this 9. So that should be 3. So what's left behind? What's left behind would be what? 10 and 3. So times 7. So 10 times 3 times 7. That's 21 times 10, 210. So what does that supposed to mean? That means you have 210 different cases of picking 4 books out of 10, right? That's what it means. All right, and that's the example that that's the formula, and that the example that we just checked. Now, the next one is what's called permutation. Now, this case is very similar to our previous one, which is combination. Permutation, they use P. The notation is almost the same. But look at that. This is n factorial, n upper n minus lower n factorial. The combination had another lowercase n factorial right there multiplied, but permutation doesn't. And what's the main difference? In permutation, order of selection matters. That's the main difference. In combination, for example, the book example that we had, it doesn't really matter which book that you choose first. You are going to take 4 books anyway. Doesn't really matter which one that you choose first, or the second, or the third. But in some other case, selection of order sometimes matter. For example, let's say you have group of, say, 8 students, and you are picking 1 president and 1 vice president. Well, then the one who got picked first is going to be the president, and one who got picked second is going to be the vice president. In that case, order matters. And think about it. If you have like 8 students and you try to pick 2, 1 president, 1 vice president. So how many different ways can you pick? How many different ways can you pick 1 vice president and 1 president and 1 vice president out of 8 students? Well, how do you calculate that? You calculate that with the permutation. Why do we use permutation instead of combination? Combination would be the case that we don't have to worry about the order. Permutation is the case that order we do have to worry about it. All right, so let's try that question as well, right? So let's say you have 8 students and pick president and vice president. So mainly pick 2. But order matters. Then we use P out of 8, pick 2. And that would be 8 factorial over 8 minus 2 factorial. So 8 factorial could be what? 8, 7, 6, 5, 4, 3, 2, 1. And 8 minus 2 would be 6 factorial, right? 6, 5, 4, 3, 2, 1. So you can see that all these will cancel out. So you end up having 8 times 7, 56. Meaning what? You have 56 different ways of picking one president and one vice president out of 7 students. It could be scientist, it could be a member, whatever, right? Out of 7, picking 2, order matters. And that's when we use this permutation. Okay? All right. So let's go back to this. And, let's talk about assigning probability. We talked about this. Probability is going to be between 0 and 1. That thing right there. Let's talk about this. I want to make a point there. See this notation? 0 p e I less than equal to 1. What does that supposed to mean? What do you think this p means? This is probability. Right? What do you think this E means? This E right here. What do you think that refers to? That refers to event. Well, they want to make it general, so they say this event number 1 or event number 2, so they use this EI. But this would be an event. In actual example, you will put your event or description of event there. And it's going to be, so probability of any event is going to be between 0 and 1, right? And we talked about that, right? Okay. So that says it right there. Now, if you consider every single possible event in one experiment, when you add all the probability, it's gotta be 1. Of course, flip a coin. Let's talk about flipping a coin case. Your event could be getting head and getting tail. Can you get anything else when you flip a coin? No. So what would be the probability of getting head? 0.5. What would be the probability of getting tail? Another 0.5. When you add those two, it's gotta be 1. Right? That's what they mean by this, right? Sum of probability of all experimental outcome of certain event must be equal to 1. Okay, so how do you assign probability? Well, there are several different techniques and several different ways of assigning probability. A classical way would be just assigning probability based on assumption of equally likely outcome. For example, when you flip a coin, what's the probability of getting head? Well, it's a 50%. How do you know? Well, it's based on this, right? You assume that equally likely outcome, you have only 2 chances, so it's going to be head. Now, relative frequency method would be assigning probability based on experimentation or historical data, right? So if you have some type of historical data for certain probability question, then you can answer this probability using the relative frequency method. For example, what's the probability of getting the first snow on November, for example? Well, if you have all the historical data that the case that actually first snow on November, then you should be able to answer this. For example, past 100 years, there was 5 case that there was a snow in November. If you have that historical data, then you can say it's 5%, right? subjective method, and this is assigning probability based on your own judgment, right? So it's not historical data, not equally likely outcome, but based on your own judgment. Then it's another possible way of assigning probability. So we talked about the classical method, equally likely outcome, talk about rolling a die case. You can get 1 through 6. Those possible outcome, if you collect all those possible outcome, what do you call that? You call that sample space. Now, I want you to take a note on this. What's sample space? Sample space consists of all possible outcome. When you roll a die, sample space is going to be 1, 2, 3, 4, 5, 6. If you flip a coin, what would be the sample space then? Head or tail, right? Okay. So let's say Lucas Tool Rental would like to assign probability to the number of car polisher it rents each day. So this tool rental company renting polishing, I guess, car polishing kits. Someday they rent out none, someday they rent out up to 4 units. So the office records show the following frequency of daily rental for past 40 days. So this company has a history of past 40 days. So out of those past 40 days, 4 days that they didn't rent out any. 6 days they rent out 1 unit. 18 days they rent out 2. 10 days 3. 2 days 4. Okay. Now, if that's the case, how do you assign probability? So if that's the case, what would be the probability that you will rent out 0? Well, it would be 10%. How do they get this 10%? Well, they divide this 4 out of total number 40, right? That's how you that's how you calculate this probability, right? How do you figure out this 15%? Well, 6 divided by 40. How do you figure out this 25%? Well, 10 divided by 4, right? So you can get all this probability based on the past 40 days records. Sometimes you can just figure out probability. Sometimes you have to calculate based on the record. Sometimes that you have to make your own judgment, basically, right? So let's say sometimes you just have to make an estimation, and remember that Bradley investment case, there's 8 different case, right? And net gain or loss was this, and let's say your analyst made this type of probability estimation. So they say, so that you're just making up this stories, right? They're making up this probability. Your analyst that you hired was saying that you have 20% chance of getting this much, and you have 8% chance of getting this much, for example, and you have 6% chance of losing this much. And this table describe all those possible probability cases. And we're going to use this table later on in the following chapters. Okay, all right.